All right, section 9.2, special right triangles. So starting off with the theorem, we have the 45, 45, 90 triangle theorem. In a 45, 45, 90 triangle, the hypotenuse is, right here it should say, root 2 times as long as each leg. So again, in a 45, 45 triangle, 45, 45, 90 triangle, the hypotenuse is root 2 times as long as each leg. So in this diagram here, and this is a good diagram to just kind of embed in your memory, we've got a 45, 45, 90 triangle. Each side length, each leg length is n, right? Here and here is n. And the hypotenuse is n times root 2. Now, if you're able to remember this picture, it'll make a lot of homework problems go by really quickly. Because some of the homework problems will have a triangle here, and it'll be a 45, 45, 90 triangle. And it'll tell you, well, these are both x, and maybe this is 10 root 2. If you remember this picture really quick, well, you know instantly that x equals 10. Right? Right away you can say, well, x is 10. Okay? Something to go along with this is that it's going to be important that we write things in simplest radical form. Right? We have to leave the root. We can't put it as a decimal. We have to leave the root. Next up, just a neat picture that we want to say. A 45, 45, 90 triangle is an isosceles right triangle. Isosceles, meaning that there's two congruent sides that can be formed by cutting a square in half diagonally. Right? So we have this neat picture here of the square. All four sides are equal. All four angles are equal. We have an angle bisector here, and what that does is it cuts each of these evenly. It divides them in half, so 90 divided by 2 gives us 45. And then you could also use this theorem, the theorem that we listed right above, to find that this is always, if this is x root 2. And that can be useful sometimes with squares. And it's not just a triangle. You find the triangle hidden inside the square. All right. Again, that is 45, 45, 90. Next up, we have 30, 60, 90 triangles. So these are also special right triangles. And you can read the text there. Actually, no, what is this? The longer leg is 2 times as long as the shorter leg. Oh, excuse me. The longer leg is root 2. Sorry, I was reading an earlier spot. Root 3. Right here, there's the 2 times as long, and then we have the root 3. So we have these formulas over here, if you'd like to use them. But I normally look at this picture here. And again, I think this picture is good to embed in your memory. We have 3 different lengths here. We have n root 3, and 2n. And it's good to memorize them in that order, right? That's smallest to biggest. N is the smallest. N root 3 is the next smallest. So let's go ahead and type in root 3 just so we know. Root 3, this is about 1.7, right, which is less than 2. Notice that we have the largest angle, the 90-degree angle, is opposite the largest side. That's the 2n. The second largest angle is the 60-degree angle. It is opposite the n root 3, which is the second largest, second smallest. It's the middle side length. And then we have the smallest angle, the 30, and it is opposite the smallest side length. All right, so it's good to remember that. Again, this is another one of those that you could just kind of look at this on some homework problems, some test problems, and know the answer right away, right? If you had a triangle like this, and I don't know, this was 8, then you could label 4 and 4 root 3 pretty instantly, because 8 was the hypotenuse. You could rewrite that as 2 times 4. And once you rewrite that as 2 times 4, then it falls perfectly with 2n. And then you can just plug in n for the other side lengths. All right, so let's look down here. Number 8, find the value of x. Write your answer in simplest form. So this is we have a 90-degree angle, and then we have a 45-degree angle. Because this one's 45 degrees, we could use the fact that triangle angles out of to 180 to figure out that this one's also 45. So it's a 45, 45, 90 triangle, and the hypotenuse will be 10 root 2 using our theorem listed above. And there we are. That's all the work. Next up, this one, it only lists the right angle. But the other thing that it does is it lists that both of these side lengths are x, which makes it an isosceles triangle, which makes these angles equal, so that forces them to be 45 degrees. Okay. One way to think about why those are forced to be 45 degrees would be to say, well, we've got, I don't know, I'll say A. A is our angle measure. A plus 90 is 180. And if you were to solve that, you would end up getting A equals 45, right? Because they have to be the same. So right there, I can look at my hypotenuse as 6 root 2, and I know that x is going to be 6. All right, scrolling down. Number 9. Again, we're finding missing side lengths. Right here on the left, x is going to be equal to 4. It's a 45, 45, 90 triangle, and I just look at my hypotenuse, and I take out the root 2. To the right, this is our first 30, 60, 90 triangle. They're a little bit harder to see, but it's always good to remember that we have n root 3, then we have n, and we have 2n. So looking at our picture here, we can tell that n is 4, right? N is 4. So over here we could say, well, this is 4, and this would be 8. So x equals 4, and y equals 8. Scrolling down, I look at this one here. Well, here we need to really think about this. Our smallest side is across the 30 degrees. It's right there. So that's going to be our n. Across our 90-degree angle is 2n. And then down at the bottom is going to be n root 3. This one's going to get a little uglier because we don't have a root 3 in there. We just have a plain old 12. So here we're going to have to use the idea that the long leg times root 3 equals the short leg. That's how I'll abbreviate that. LL is long leg, short leg. And now I'm going to plug in my long leg. Excuse me, I wrote that incorrectly. I'm sorry. Here we have the short leg, and here we have the long leg. I wrote them on the wrong sides. So the short leg times root 3 is the long leg. Yeah, that makes more sense. So the long leg here, I'm going to plug in for 12. So we have short leg times root 3 is 12. Now to get the short leg alone, I'm going to divide by root 3. So I'm going to say, well, this is short leg equals 12 over root 3. Now we've solved it, but I need to rationalize. I need the denominator to not have a root in it anymore. To get rid of that, I'm going to multiply by root 3 on the bottom and on the top. On the top, that turns this into 12 root 3. On the bottom, my root 3's cancel, or they don't cancel, they combine. The roots go away to just be a plain old 3. Now the 12 and the 3 can cancel to be a 4. So I get 4 root 3. So that is my short leg. So that's x equals 4 root 3. Now my hypotenuse is always 2 times the short leg. So this is going to be 2 times 4 root 3. So 2 times 4 root 3. Well, 2 times 4 is 8 root 3. So that's going to be my y, my hypotenuse. Or here, I'll circle that. So there we are. That one's a little bit of a longer problem, but there will be homework problems that are similar to that. Next up, we're back to easier problems, 45, 45, 90 triangle. This 3 is our side length. We could also put that over here for this other side length. And we know that our hypotenuse will be 3 root 2. There we are, nice and easy. All right, and that's it. So make sure that you have copied down this problem. This is the hardest problem on here. Make sure that you're able to follow what I did in that one. Let me know if you have any questions.